Alright, my name is Kayla Bennett. This is factoring a quadratic function, class 3B. Okay, so first what we have, our first example is going to be a greatest common factor. And first what we're going to do is we're going to find the greatest common factor of all three of these numbers. Well, 10, it will go into 60 and 80. So 10 is going to be our greatest common factor. And since there's x on 60 and 10, but not on 80, we can't have 10x. So we're going to factor out 10. So 10, factoring out of 10x squared will be x squared minus 6x plus 8. Okay, and so now what we're going to do is we're going to stop looking at this and we're going to look at this. We're going to factor out x squared minus 6x plus 8. So what we're going to do is we're going to set up our parentheses and see, I know that this will have to be a positive and this is going to have to be a negative, and I know that a negative and a negative make a positive, so I'm going to go ahead and put my signs and go ahead and bring the x down. So x and x. And so we're going to have to find the common numbers between 8 and 6. So we have 1 and 8, 2 and 4, and 4 plus 2 is 6. And so what we're going to do is, since they're both negatives, it doesn't matter. 4 and 2. And we're going to check ourselves. And so we're going to FOIL this, and FOIL is first, outside, inside, last. So first is x squared. Outside is going to be minus 2x. Inside is going to be minus 4x. And our last is going to be minus 8. And then we're going to put together our common multiples and get x squared minus 6x minus 8. So that is how to solve a greatest common factor quadratic function. Alright, and now we're going to do a difference of perfect squares. Two perfect squares. Alright, and our equation for a perfect square is going to be k squared minus 49. Okay, and what I know is that this is going to be a and that's b. And I know that when our equation for perfect squares is a minus b, a plus b. And so a is going to go right here, and so k plus, well, k minus, and then k plus. And so we have to find two numbers that equal 49, which we know is 7 times 7. 7 times 7 equals 49. So this is going to be our, what we get after we find the difference. And if you want to check it, you can check it. You're going to do the FOIL method again. Or if you don't want to do the FOIL, you could do box method. And we're going to do the box method. Okay. So k squared minus 7k, 7k, and 49. So when you equal all of this together, you're going to get k squared plus, minus 49. And then that equals that. Okay? And our last example will be an easy case where our a value equals 1. Okay, so this is going to be an easy case. Going to be an easy case. Our equation for an easy case is going to be x squared plus 15x minus 26. And now for this you can do the FOIL method, the box method, or the diamond. But this is how to figure out if it's right. The foil and the box are to check it, but the diamond is to figure out what your answer is going to be. So we're going to try a diamond method. So this is A, B, and C. We know C goes up here, and so negative 26, and then 15, and then B goes right here, and so 15 would be right here. And so we have to figure out which two numbers equal negative 26 when multiplied, and what numbers equal 15 when added together. And so we're going to use numbers 2 and 13. So 2 and 13. And see how that is a negative? We're going to have to make, sorry. That is positive 26. Positive 26, sorry. And so both of these are going to be positive since we don't have a negative. And so we're going to have x squared plus 2x plus 13x plus 26. And we're going to pretty much just split this right here. And so we're going to have x squared plus 2x 13x plus 26. No. Wait. Yeah, okay. So now we're going to take out our greatest common factor out of both of these. And for this, we're going to take x out. So then it will be x plus 2. And we're going to take 13 out of that, positive 13. So we're going to have x plus 2. And these should always equal each other. If they don't equal each other, then you need to recheck your answer. And so we're going to take x and 13, and so that will equal x plus 13. And so our answer is going to be x plus 2, x plus 13. And we're going to check it. We're going to check it. And so for the checking, I want to do the FOIL method. And so we're going to do first, it stands for first, outside, inside, last. So we're going to have x squared for the first. Now the outside, and we're going to get 13x. Inside, 2x. Last is 26. Now we're going to combine those, get x squared plus 15x plus 26. And that equals that. And these are 3 examples of different kinds of quadratic functions. Thanks for watching.